applies. And so we can sort of take this away as a general rule about competition. First of all, eventually, but not immediately as the number of firms increases, competition drives prices and costs. And with enough firms, price should be close to efficient. Yeah,
Is
David?
this assuming that every firm has the same cost curve, or does it not matter?
No, they can be different, but the key thing needs to be that each firm becomes a small part of the industry as the number of firms increases. So it's not really that every firm's the same, but that as the number of firms increases, that every firm doesn't have such a Zipf's law type advantage, as Terence was pointing out, that it remains
But the point
large.
is they all eventually have to arrive at the same marginal cost, right? Because they're all providing the same price.
Well, then a lot of those firms are going to be driven out. The low firms are going to be driven out of the industry, and only the top ones will survive. So a natural question is how many firms is enough, right? So Bresnahan and Race did a very clever study of this. So they noticed that, as a market gets larger, it can support more firms, right? So in particular, imagine we have like a small town, right? If the small town is like 500 people, there might only be one dentist. But if it has like, 2,000 people, there might be 2 dentists. If it has 7,000 people, there might be 7 dentists or whatever, right? So let's say that the number of people required to support n firms is at capital S sub n, right? So if the town size at which there gets to be a 4th dentist is 5,000, then S sub n would be 5,000. And then let's call little s sub n the number of people per firm needed to support that many firms. So if again that was 5,000 and 4 dentists, then there would be 1,250 would be the number of people per dentist needed to support 4 dentists, right? Okay. So this represents the number of consumers per firm at different numbers of firms. And notice that if prices stayed constant as the number of firms increased, and the fixed cost of each firm was the same, then this little s sub n would be constant as the number of firms changed, right? So imagine that the town doubles in size, and everyone's still charging the same price. Well, you would think that there would be twice as many dentists, right? Because twice as many dentists, they would all have the same number of customers, right? And that would be just enough to support the thing. So we can take it potentially as an indication that prices are falling as the number of firms increase if more customers are required to support a second dentist than were required to support the first dentist. And if there were more customers required to support the third dentist than were required to support the second dentist, again, that indicates prices would be falling. So that would be the same as the S sub 3 being smaller. Sorry, this should be reversed. S sub 3 should be greater than S sub 2, and S sub 2 should be greater than S sub 1. Another reason that this could happen is that imagine that the first dentist who comes in is the dentist who can enter most cheaply, and then the next dentist, it's more expensive for him to enter, and so forth. That would lead to the same pattern. But let's just interpret it that way for now. It's sort of a nice, simple way to think about what might be going on. So what Bresnahan and Race did is they found 5 professions and a bunch of rural towns, and they found out how many people lived in each town and how many dentists or mechanics or whatever there was in each town. And then they looked for the level at which S started to level out rather than continuing to rise, because this indicates the point at which we've sort of reached as low as prices are going to get. And they found that this was around 3 to 5 professionals. So here's the graph that they did. This one is for druggists. The triangles for druggists. The diamonds are for tire dealers. The circles are for doctors. The squares are for dentists. And the crosses are for plumbers. And this shows the ratio of the number of people needed to support 5 firms to the number of people needed to support 1, 2, 3, 4, 5, or 6 firms. And you see this sort of comes down rapidly as you get towards 3 firms. The biggest difference is when you move from 1 to 2, and then there's a somewhat smaller difference from 2 to 3, but then very little happens from 3 firms on. right? So what that indicates is that sort of 3 or 4 firms seems to be, in these industries at least, enough for the industry to be very competitive. Okay. So, so far what we've assumed is that all the competing firms had exactly the same product. But in the real world, much competition comes from firms that have different products, right? That are imperfect substitutes from one another. And now I want to think about what does the competition or the removal of competition do to prices in that type of an industry? Well, that's a little bit tricky because the question is, what do we even mean by competition here, right? Because in a differentiated product industry, a new firm coming into the industry doesn't just compete, it brings a whole new product. So that changes things in a way that's different than just removing competition or creating it. So the simplest way to think about it is if we take an industry and we take 2 firms that merge with one another, that's sort of removing competition without changing the products that are offered. And how does that affect prices? 2 things that were separately owned, Burger King and McDonald's, now are owned by one company. And so even though they're still offering Burger King and McDonald's, they're owned by the same company. So let's consider sort of the simplest model of this situation. Imagine that each firm has a linear demand function. Their quantity depends linearly on their price and the quantity of the other firms. So imagine that they have a common constant marginal cost, and let's assume that the price decreases more quickly in their own price than it increases in the price of their rival, right? What is going to be the optimal price for each firm? Well, we can just do quantity times price minus cost, take the derivative of that, and what we get is that price minus cost is equal to quantity over the derivative of quantity with respect to price, right? That's the equation that we've done many times in class. The markup is equal to quantity over the negative of the derivative of quantity with respect to price. And so that gives us alpha minus beta pi plus gamma pj over beta. And then we can simplify this right-hand side to be alpha plus gamma pj over beta minus pi, right? Because the betas divide through here. And then if we bring that to the other side of the equation, we get that pi times 2 is equal to c plus this. If we then multiply c by beta and divide through and make a common denominator, then divide through by 2, we get this equation. The price is equal to beta c plus alpha plus gamma pj over 2 beta. Do people want me to go through and do the algebra there? Would people like to see that? Raise your hand if you would like to see that. Okay, people want to see the algebra. Okay. Okay, so we got that pi minus c is equal to q over negative q prime, right? And q is just that expression, and q prime is beta, right? Because the derivative with respect to pi is negative beta, so negative q prime is beta. So this is equal to alpha minus beta pi plus gamma pj over beta. Okay, so that, dividing through by beta on the pi, is alpha plus gamma pj over beta is equal to pi. Sorry, minus pi. Okay, so now we can bring this pi to the other side of the equation and put the c on this side. So we get 2 pi is equal to c plus gamma pj, alpha plus gamma pj over beta. So now we can make a common denominator with c, and that's going to be c plus alpha plus gamma pj over beta. Right? Divide both sides by 2, and we have the equation that we derived up here. Okay. So then by symmetry, the two prices are going to be equal to one another in equilibrium. So we can take this pj and say that it's going to be the same as pi. Bring it over to this side. So we get 1 minus gamma over 2 beta times p is equal to this. And that gives us this final equation that the pre-merger price is equal to beta times c plus alpha over 2 beta minus gamma. Okay. By the way, just so you guys know, the reason I do algebra in these things is not because it's important that you master this particular algebra. The reason that I do algebra is because I got strong demands from you guys that you want to see me go through various algebra things. So this is not like absolutely crucial that you master this particular derivation. The point is I'm just trying to show you the sorts of like algebra things that you might do on homework, just so you get a sense for some algebra. But it's not like you have to absolutely master this particular algebra. That's not the point. The point is to get a sense for like doing some examples of the sorts of things that you might do on. Okay. So after the merger, by symmetry, the firms can basically treat the two products as if they were just one product, right? So now that product is going to have demand, which is 2 because there's the two products, times alpha minus beta minus gamma times p. Why is that? Because the two prices, they're treating the two products as if they're the same product, and so they're just going to charge one common price for the two things. And if you just plug in the same common price into this equation, you get minus beta minus alpha, gamma. And so the optimal place to price on this demand curve the optimal place to price on this demand curve is just halfway up it, right? This is just the monopoly problem that we were doing. What's the point at which there's no demand? Well, it's alpha over beta minus gamma. Halfway up that is 1/2 alpha over beta minus gamma. Plus 1/2 of the cost, right? Because the pass-through rate of cost is 1/2. And so that gives us beta minus gamma times c plus alpha over 2 beta minus gamma. So what's the difference between these two things? Well, I don't expect you to be able to do it in your head, and I don't want to go through more just manipulation. So if you just plug this into Mathematica, we get the following expression. 1/2, the change in prices is 1/2 times gamma over beta minus gamma times alpha minus beta minus gamma c over 2 beta minus gamma. Okay, what the heck is that? There are basically 3 crucial factors here. The first one is the intensity or the closeness of competition between the two firms. This is gamma over beta minus gamma. And Edward? Yeah. Why is gamma over beta minus gamma the intensity or closeness of competition?
Is it just the rate that the prices change when quantity changes?
Yes, but in particular, why this number in particular? Why is this